In today's lesson, we're going to spend more time looking at numbers. Specifically, we're going to start looking at integers, so positives and negatives and the operations that happen between them or amongst them. We're going to start with what I would consider probably the two easier ones. Not that integers are necessarily easy, but we're going to look at multiplying and dividing first because they only have two rules. Okay. First of all, let's talk about integers. Integers are whole numbers. Whole numbers that could be positive or negative or zero. And we can usually put them on a number line. That's kind of probably where you started back in elementary school. So on a number line, 0 lies in the middle, and on either side of that, we get bigger and we get smaller. As we go to the right, those are bigger numbers. 1, 2, 3, 4, and so on. As we go to the left, we call these smaller numbers -1, -2, -3, and so on. The further to the right you are, the bigger your number becomes. Further to the left, the more negative it becomes. We say those are smaller numbers. So let's try something, just get warmed up here. Let's order these values from smallest to largest. So if I scan the numbers, what I'm looking for is I'm looking for the negatives first. I'm actually looking for the big negative numbers, right? Because those are technically smaller. So the smallest number I see would be -7. It's furthest to the left on the number line. And the next smallest would be -4. We're getting towards the positives. We're still in the negatives. Then -2. Then I see a 0. And now we're into the positives. I got 1. I got a 3. I got a 4. A 5. And a 6. Let's make sure I didn't miss any. 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers in the question. 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers in my answer. Okay, we'll try another one. Just getting warmed up here about integers. Can you write an example of the following? Give me an integer greater than -2. So again, if we talk about our number line, here's 0. -2 would be over here. Things greater, in other words, larger than -2, are on this side. So I could use -1 or 0 or any positive number. So -1 or larger will work. I just give you a bunch of options there, right? 0, 1, 2, 5 million. Okay, an integer less than -5. So on the number line, -5 would be over here, and I need to be less than it. So I have to be over here on the left-hand side. So for instance, -6 or -7 or anything smaller than that. An integer greater than -3 but less than 2. The good news is on our number line, I can see those things. So anywhere in this range. Okay, so I don't know what's a good example, -2 maybe, or 0, or 1. There's some options. How about an integer between -4 and 3? There's -4. There's 3. Anything in between those two things? Let's try a +1. An integer between 8 and -5. Well, again, anything in between those things. Let's pick 0. 0 is a nice integer. The number 0 is actually a really nice number to work with because when we use 0, it doesn't really do much, right? Okay, no warm up on integers. What's next? Let's talk about how we multiply and divide integers. There are two rules we have to know when we multiply and divide integers, and they basically depend on the signs. When you're multiplying or dividing, check the signs first. If the signs are the same, it results in a positive. In other words, a positive times a positive or a negative times a negative. If you have that, the same signs, always positive. If your signs are different, it results in a negative. So the options are a negative times a positive or a positive times a negative. Okay. Once I've dealt with the signs, I'll have to worry about the numbers afterwards. And we're going to try and do today with some mental math, if we get some practice with it. If you have to use a calculator, it's okay, but let's try and do some mental math today. So let's take a look at some questions here. Okay, first question, calculate. -4 times 2. I look at my signs, I see a negative, and there's no sign over here. If we don't see a sign, it's always assumed to be positive. So I've got a negative and a positive. Those are different. I know my answer is going to be negative. What's 4 times 2? It's 8. If I look at B, I've got a negative again, and I got no signs. That means it must be a positive. Those are different, so it's a negative answer. And 12 divided by 3 is 4. Look at the third one, a negative with a negative. Oh, I know my answer is positive. And 16 divided by 4 makes 4. Now, as I said, we don't usually show a plus sign in front of something. That's just an operation. We just write that as 4. The plus sign is assumed. Just like it was assumed back here as a positive, and back here as a positive. Okay, 3 times 7. Those are both positive numbers, which means I need a positive answer. They're the same sign. A negative times a negative. Those are both the same signs. So my answer is positive. 5 times 9 is 45. Ooh, here's a weird one. Negative, negative. Well, what's actually in front of that bracket? Remember we said we assume there's always a positive in front of something if you don't see it? Well, we can also assume with numbers. If we don't see a number, we can always assume the number 1 is right there. So this question actually says negative 1 times negative 5. But 2 negatives make a positive, and 1 times 5 is 5. Try G here. I've got 5 times negative 6. This must be the positive times a negative. Well, those are different. And 5 times 6 makes 30. Negative and a negative. That's a positive answer. 30 divided by 6 makes 5. And the last one here, 11 times 0. Yeah, that's a weird one. Remember we talked about that number 0 being a really nice number? Anything times 0, always 0. And if we're thinking back to like when we learned multiplying, it's 11 groups of 0, right? Well, that means I don't have anything. Okay, there's a quick warm-up of integers. We talked about signs. Same sign as a positive. Different signs as a negative. Let's go some more slightly challenging questions. Okay. 3 times negative 4 times 2 times negative 1. Well, what would that be? If I actually stop and look at the signs, I do the first two, I've got a positive times a negative. Well, that's a negative answer, and the answer comes out to 12. The rest will stay the same. We're kind of doing BEDMAS here now, right? Okay, I do a negative 12 times 2, that's a negative 24. The 1 stayed the same. Now if I do the last set, negative times a negative, that's a positive, and I get 24. Remember, BEDMAS said we work from left to right. That's what I did there. And if we try K, I've got negative 24 divided by negative 3. That's a positive 8. And everything else is going to stay the same. And a positive times a negative. Those are different signs, so I get a negative answer. And then my last ones, I've got a negative times a positive. Those are different signs, so I get a negative answer. And we're working left to right. When I deal with BEDMAS rules and multiplying and dividing, it's always left to right. I have to worry about signs today, but I'm still using the concepts we learned about last lesson. All right, last idea for today. Besides multiplying and dividing, there's one other thing that we need to deal with when it comes to positive and negatives. That's exponents. Exponents are really just a fast way of multiplying, as we talked about with BEDMAS. So instead of writing out 2 times 2 times 2 times 2 times 2 times 2 times 2, it's a way faster to write out 2 to the power of 7. It means the same thing, right? But it saves us a bunch of writing time. And we talked a little bit about exponents the other day. We called 2 our base. That's the bottom part. We call the 7 your exponent. That's how many times you're multiplying. And we call the whole thing a power. So 2 to the power of 7 is how we'd read that. If you have just a number like 2 to the 7, that's really easy to type into our calculator. Don't have to worry about signs because everything's positive. However, when you have negatives, sometimes it's a little more challenging to type into our calculator because you do have that issue with signs. So the little trick that sometimes works when you have exponents and negatives is count how many negatives you have. And I do that by examining the exponent. Okay, so we'll take a look at some examples down here. Well, there's one tricky one in here that I'm going to have to point out to you. Okay, if I look at the first one, negative 3 to the power of 5. I'm going to write this out the long way just so we can talk about it. Because what does it mean? It means negative 3 times negative 3 times negative 3 times negative 3 times negative 3. We don't really want to write that out. That takes way too long. So what we really want to think about is how many negative signs would I have? Well, 1, 2, 3, 4, 5. The same as my exponent. 5 is an odd number. Odd numbers create a certain kind of exponent. Let's think about this. Those two together make a positive, right? Those two together make a positive. So I have one extra negative sign. That means my answer is going to be a negative. And all I have to do now is figure out what 3 to the power of 5 is. 3 times 3 times 3 times 3 times 3. Now I could type that in my calculator the way it is, but again, like writing it out the fast way, we kind of want to use our calculator to do things in the fast way. So I'm going to show you on a calculator how we can type this in. I have a slightly fancier calculator, this one we use in class, but if you don't have this one at home, you can still do it as long as you have a scientific calculator. So what we're going to type in is 3, and we're going to use our power button. On this calculator, let's see if I can show you here. I'm going to move this calculator to the side here. The button above the dividing sign looks like this. Okay, it's right there above the dividing sign. That's an exponent button. On your calculator at home, you might not have that button. Maybe you have a button that has x to the power of y or y to the power of x. Those are kind of the ones we usually see. After you type in the 3, we're going to put to the power of, and my calculator goes up like an exponent, then we put the 5 in, the exponent itself. Press enter, and there's my answer, 243. Yes, my answer is negative 243. And again, I suppose you really could type it in if you wanted to negative 3 times negative 3 times negative 3 times negative 3 times negative 3, but why would you want to do that if you can avoid it, right? Okay, let's take a look at the next one. I'm just going to erase these numbers because they take up too much space. Negative 4 to the power of 4. How many negatives do I have? I've got 4 of them. If I think about that, a negative times a negative makes a positive. And another negative times a negative makes a positive. And positive times a positive, hey, that's a positive answer. The little trick is, if you have an even exponent, your answer is positive. If you have an odd exponent, your answer is negative. We'll get our handy dandy calculator out here, type it in, 4 to the power of 4, that comes out to 256. Again, we don't usually show the positive signs, so it's going to be down 256. Okay, let's try the next one. Negative 1 to the power of 9. Ooh, 9 negatives, that's a whole bunch of them. But what do I know about the number 9? I know it's odd. So my answer is negative. And I've got 1 times itself 9 times. That's not what I really need the calculator for. Because 1 times 1 times 1 times 1 times 1 times 1 times however many ones you want always comes out to 1. It's almost like a trick question. And we'll try a couple more here. Let's try D. Negative 2 to the 3 means I've got 3 negatives. 3 negatives, that's an odd number, right? And 2 to the power of 3, 2 times 2 times 2, we've seen that a few times now. That comes out to 8. E, well, on E, there's no negative signs to worry about at all. So I know my answer is positive. It's only dealing with positive numbers. And 3 to the power of 4, type that one in your calculator, you should get 81. Okay, the last one. I'm going to put a star next to it because it's different. It looks suspiciously like letter D, but it's actually a very different question. And for this one, I'm going to talk about the long way of writing out for just a second. In D, we had to do this. Negative 2 3 times, because the exponent was on the bracket, keyword there, around negative 2. I wanted to use that base 3 times. But F is different. The 3 is only on the 2, and there's no bracket that tells me to include the negative sign. So F means negative 2 times 2 times 2. Here's my base 3 times, and it just happens to be a negative sign in front of it. How many negatives do we have? Just 1. It's an odd number. So my answer is a negative. And 2 to the power of 3, as we said earlier, is 8. So in this case, the answers worked out the same. But that's not always going to be the case. In fact, if I were to give you one more question that had, I don't know, let's look at one. Negative 2 to the power of 4 compared to this, those have different answers. In the first one, I've got 4 negatives. That's a positive answer. And 2 to the power of 4 makes 16. In this one, remember this means negative of 2 times 2 times 2 times 2. I've only got 1 negative sign. Well, I got a negative answer in the 16. Those are completely different answers. So having brackets around something means something different. It means include the negative sign, or not, in your exponent work. Okay, that's it. There's some integers. We're going to try the sheet on the website as usual. So some multiplying and dividing and a little bit of exponents. It's good to know some more buttons on our calculator. We're going to get familiar with some of those because we're going to start using them down the road for other things.